Hello, 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 hello. How are you guys doing? Yes, I have shaved. Nothing to see here other than a man without beard, and it's not weird. Let's go. Today we'll revise quantum mechanics lecture 124. Okay, so lecture 1. We start with a difference between classical and quantum. What are the three basic differences? First of all, classical is macroscopic, quantum is microscopic. Classical is distinguishable. We talk about distinguishable particles. Quantum, we talk about indistinguishable particles. Classical, we are in the deterministic realm. In quantum, we are in the indeterministic realm. So, what do you mean by indistinguishable? So, it means we cannot distinguish between identical particles in quantum mechanics. Can we distinguish between identical particles in classical mechanics? We can by their position and momentum, because no two particle can have same position and momentum in classical mechanics, but in quantum it can. In quantum, the concept of position itself is not very well defined. है ना? Microscopic, very small dimensions, atomic size, nuclear size. The act of measurement is limited not due to any instrument or human error, but certainty becomes exception here, and we talk about probabilities and possibilities, right? So now we talk about, after talking all this quantum classical difference, we talk about photon. Photon has dual nature. It's a particle and it's a wave. When we talk about particle, we talk about photoelectric effect, we talk about blackbody radiation, we talk about Compton effect. When we talk about wave, we talk about reflection, refraction, polarization, etc. Right? Now, some properties of photon: it has zero rest mass, it travels with c, speed of light, and we have momentum of a photon defined as h by lambda, and energy of a photon defined by hc by lambda, right? अब light always behaves as particle when it is interacting with obstacles, but its location is governed by its wave character. Or you can say, when it is propagating, when it's traveling, it behaves as a wave. When it interacts with systems or obstacles, it behaves as particles, right? Intensity define करना है. Intensity is energy. I'm sorry. Intensity is energy per unit area per unit time. Depends upon number of photons. Energy of photon is discrete and quantized. So examples में, if you can heat a black body, it will give continuous radiation. If you heat a hydrogen gas, the spectrum is discrete. What is another example of discrete? Charge is discrete, right? तो यहाँ हम लोग फोटॉन पढ़े, फोटॉन से रिलेटेड एक physical quantity intensity पढ़े. So energy of a photon is unique for a particular wavelength. E is equal to hc by lambda. Now if there are n photons, total energy is n hc by lambda, and so the intensity is n hc by lambda by at, and you are given with how number of photons decide intensity. I is proportional to n. Radiation pressure. Uh, so yeah, so radiation pressure is pressure exerted by photon. What is pressure? Pressure is thrust per unit area. Thrust per unit area. So treat photon as a particle, and change in momentum is here. Uh, Assuming no transmission as the photon cannot penetrate the surface, E incident is equal to E reflected plus E absorbed. So we get this relation R plus A is equal to 1, where R is coefficient of reflectivity, A is the coefficient of absorptivity. And case 1, all photons are absorbed होना चाहिए, यहाँ पे हम लोग observed लिखे हुए हैं. Aren't we stupid? Yes, we are. Okay. So suppose there is a photon with momentum minus h by lambda, not minus, h by lambda. It strikes a surface, sticks to it. Change in momentum minus h by lambda. Force acting on it minus h by lambda by delta t. Okay, we have to. Now total force acting on the surface is number of photons times force exerted by one photon. So the number of photons incident by area into time is equal to intensity by energy of one photon, which is I by hc by lambda. Mathematical manipulation, and you are left with I lambda by hc. So radiation is number of photon incident into change in momentum due to one photon by area into time. So I lambda by hc into h by lambda, you get I by c. So I by c is radiation pressure if it sticks, where I is intensity, c is speed of light. Ab, if it all gets reflected back, the change in momentum will be minus 2hc by lambda, sorry, minus 2h by lambda, and the radiation pressure would be 2I by c, right? For a general case, we can write radiation pressure is equal to I by c into 1 plus R, where R is the coefficient of reflectivity. If complete absorption, R will be 0, so you get I by c, and for complete reflection, I will be R will be 1, so you'll get 2I by c, right? So here we have a question. Angle of incidence of beam of photon is theta with normal. So find the radiation pressure exerted by it. It comes out to be cos squared theta term comes out. So number of particles by time is equal to intensity by energy of one particle into effective area. And effective area you can write a cos theta, and then you have it. Radiation pressure is equal to this. लैम्डा कट जाएगा, h कट जाएगा, 2I by c, a कहाँ गया? Right. I have a doubt in here. How do you explain this? ठीक है, अब हम लोग पहला टॉपिक पढ़ते हैं जो एक्चुअली सिलेबस में मेंशन्ड है. आफ्टर 3 टॉपिक्स हम लोग मेन टॉपिक पे जंप कर रहे हैं. दैट वाज क्लासिकल वर्सेस क्वांटम, फोटॉन एंड इंटेंसिटी. ये 3 टॉपिक हम लोग पढ़े पीछे, अच्छे से पढ़े. एंड नाउ वी जंप टू वेव पार्टिकल डुअलिटी, द फर्स्ट टॉपिक ऑफ द सिलेबस. इससे पहले कोई भी टॉपिक सिलेबस में नहीं था. बाय सिलेबस वी मीन यूपीएससी सिलेबस, राइट? Any substance like matter, like electron and radiation, for example, photons, exhibits both particle and wave-like characteristics depending upon how we measure it. Most important concept on which quantum mechanics is based upon is wave-particle duality. Suppose there is a particle, so it will have well-defined position and momentum. If there is a wave, there will be superposition, some phenomena like interference, refraction, etc. If it is dual, it will be detected and interact as particles, but uh, it will propagate as a wave. The probability of finding at a place is governed by wave, right? Okay. Observing a single electron at a time, all electrons are colliding in random fashion, treating as a particle. Okay. So let me. Yeah. So anything else? Same experiment in big setup. Okay. Now we study complementary properties. Wait, first second आ कहाँ से रहा है? This is third written, but then where is the first? First second. This might be the case. Third. पूछ लेंगे हम इसको भी. ठीक है. हाँ. Complementary properties we mean in quantum mechanics by canonical conjugates, which means two physical quantities are said to be canonical conjugates if you know uncertainty in P, change in P is proportional to 1 by change in Q. Like position and momentum are canonical conjugates. Quantum superposition. I don't understand. ये किसका properties है? I really don't understand. किसका properties है? Simultaneous occupation of multiple states. Observer effect or Heisenberg effect. Observer affects the behavior of the system or perturbs the system. Principle of complementarity. Hmm. Either particle or wave, not both is shown. One character at one time. At one time, complementary but exclusive. Right. तो ये लेक्चर 1 कंप्लीट हो गया. आई हैड वन डाउट इन दिस, इसको हम क्लियर कर लेंगे. सेकंड, डिब्रॉय हाइपोथेसिस. डिब्रॉय हाइपोथेसिस, इसको डिब्रोगली हाइपोथेसिस कहते हैं यहाँ पे. डिब्रॉय हाइपोथेसिस. Wave nature is associated with moving particles. So lambda is equal to h by p, h by mv, where h is Planck's constant. The value of Planck's constant, remember, 6.62 into 10 to the power minus 34 joules second. Lambda is proportional to 1 by p. Wave nature increases, particle nature decreases, and vice versa. Experiments that supported: Davison-Germer experiment, electron diffraction; Thomson's parabola experiment, that is electron diffraction from polycrystalline thin film, uh, deflection of cathode rays. ये सब याद करना होगा. इलेक्ट्रॉन इंटरफेरेंस एक्सपेरिमेंट, YDSC विद इलेक्ट्रॉन्स. ठीक है. न्यूट्रॉन इंटरफेरेंस, राइट. C60 मॉलिक्यूल्स डिफ्रैक्शन. तो 5 एक्सपेरिमेंट्स दैट सपोर्ट डी ब्रॉय हाइपोथेसिस is Davison-Germer, सबसे famous. Thomson parabola experiment. You have electron, sorry, YDSC with electron, basically electron interference, neutron interference, and you have your C60 molecules diffraction. Association with Bohr's model. So Bohr's का second postulate है Niels Bohr का angular momentum quantization, which says 2 pi r is equal to n lambda, which is nh by p. So you write rp is equal to nh by 2 pi. So L is equal to nh by 2 pi. And so if you assume Bohr's postulate as true, you can prove de Broglie hypothesis. If you assume de Broglie as true, you can prove Bohr's hypothesis. That's the way. So 2 pi r is equal to n lambda. Lambda can be written as h by p. So nh by p. So 2 pi r is equal to nh by p. So pr is equal to nh by 2 pi. There you go. Propagation vector या wave number gives the direction of propagation of matter wave. So we write it as p is equal to h cross k, where k is the wave number. It's a vector. H cross is h by 2 pi. We call it reduced Planck's constant. It is 1.05 into 10 to the power minus 34 joule second. Right. So similarly, we can derive E is equal to h cross omega. H cross का वैल्यू कितना होता है 1.05 into 10 to the power minus 34. H का वैल्यू कितना होता है 6.62 into 10 to the power minus 34 joule second. Some useful formulas derived before uses: non-relativistic. L is equal to h by lambda is equal to h by p, h by mb, h by root under 2 mk. Right. Relativistic में इसी को लिखेंगे lambda is equal to h by p is equal to hc by root under 2k into k plus 2mc. Sorry, गलती हो गया. hc by root under k into k प्लस 2m0 c स्क्वायर, राइट, जहां m0 रेस्ट मास है। इसको कैसे प्रूफ करेंगे? इसको प्रूफ करेंगे हम लोग उस रिलेशन से। कौन सा रिलेशन? ई टोटल एनर्जी को आप लिख सकते हैं काइनेटिक एनर्जी प्लस रेस्ट मास एनर्जी, ई इज इक्वल टू के प्लस एम नॉट सी स्क्वायर, स्क्वायर कर देंगे तो के स्क्वायर प्लस एम नॉट स्क्वायर सी फोर प्लस 2k एम नॉट सी स्क्वायर, and if you write the relativistic relation E square is equal to P square C square plus M naught square C to the power 4, and from there you go P is equal to root under 2k into M naught C square plus K square by C square, and from there you can have it, right? Simple. How to check if this is a relativistic case or non-relativistic case? अगर given energy rest mass energy से ज्यादा है तो it's a relativistic case, right? If it is an electron, the rest mass energy of an electron is m naught c square, which is 0.511 mega electron volt. If energy is equal to 2 mega electron volt, it is relativistic. If it is given 2 kilo electron volt, it is non-relativistic. Why? Because it is lesser than 0.511 mega electron volt, right? हाँ, तीसरा थर्मल न्यूट्रॉन, तो वी राइट लैम्डा इज इक्वल टू h by root under 2m kbt, where kb is Boltzmann's constant. Boltzmann कांस्टेंट का वैल्यू ही नहीं लिखा हुआ है यहाँ पे, बताइए। Boltzmann कांस्टेंट इनटू टेम्परेचर एट 300 केल्विन का वैल्यू होता है 0.026 इलेक्ट्रॉन वोल्ट। इसको हम kb का वैल्यू लिख लेंगे। आई थिंक आई शुड राइट इट हियर, लेट मी सर्च एंड राइट, हमको याद नहीं है। वैल्यू ऑफ माय Boltzmann was a big guy, dude. बहुत बड़ा आदमी था बोल्ट्जमैन, बेचारे को कुत्ते की मौत मिली। 1.38 into 10 to the power minus 23 meter square kg second inverse square Kelvin inverse, ये क्या यूनिट है? हम लोग इसको जूल केल्विन लिख सकते थे। अबे यार, ये क्या यूनिट है भाई? लिखो जूल केल्विन, एनर्जी होता है केबीटी, एनर्जी का यूनिट जूल हो गया, टेम्परेचर का केल्विन हो गया, तो जूल पर केल्विन, जूल पर केल्विन, ठीक है। तो lambda is equal to h by root under 2m kbt, where kb is Boltzmann's constant, its value is 1.38 into 10 to the power minus 23 joule Kelvin, and kbt at temperature 300 Kelvin, we have to remember it's around 0.026 electron volt, right? There you go. Electric potential, lambda is equal to h by root under 2m qv, right? In terms of electric potential, the lambda and v, are inversely related to the root. Derivation ये किस चीज का है? For a matter wave, it has assumed this, and then you say things like this. अच्छा, lambda is equal to h by p को derive किया है। How stupid! It's an hypothesis. You don't derive this thing, but याद करना है। For a matter wave in S frame, we write psi is equal to psi naught sine 2 pi nu t. Nu is the frequency, and S prime frame psi is equal to psi naught sine 2 pi nu t prime plus x v prime by c square root under 1 minus v square by c square. ठीक, now psi is equal to psi naught sine 2 pi nu 1 t plus x v1, x by v1, where इसको आपने मैनिपुलेट किया बेसिकली, राइट? इसको आपने बेसिकली लिखा इन अ पर्टिकुलर फॉर्म, तो यहाँ पे न्यू वन इज इक्वल टू न्यू बाई रूट अंडर 1 माइनस वी स्क्वायर बाई सी स्क्वायर हो गया, एंड v1 जिसको आप मान रहे हो वो है सी स्क्वायर बाई वी, यही है। देयर इज सम प्रॉब्लम इन हियर दैट आई कैन नॉट सेंस, The problem is न्यू वन तो ठीक है. uh, there is some problem in there. क्या है problem? The problem is कि आपने न्यू वन टी प्लस एक्स बाई वी वन को लिखा है न्यू टी प्राइम प्लस वी एक्स प्राइम बाई सी स्क्वायर, राइट. हमको नहीं समझ में आया. झूठ नहीं बोलना चाहिए अपने आप से. नहीं समझ में आया तो ठीक है. लेट्स सी, थोड़ा सा कुछ जुगाड़ निकालते हैं. इनफैक्ट हमको फ्रीक्वेंसी का ट्रांसफॉर्मेशन समझ में आ गया, हमको वेलोसिटी का नहीं समझ में आया, बट ठीक है, ये को बात है. v1, ओके. ओह, सो इफ यू आई अंडरस्टैंड दैट तब तो फिर इसमें कोई दिक्कत ही नहीं है, right? इसको पूछ लेंगे. अदर देन दैट आई अंडरस्टैंड. हाँ, बाकी सब this question is just formula based. Division and German experiment. Aim is studying the angular distribution of electrons scattered by nickel crystal. So we were studying scattering of electrons, mind you. We were not studying diffraction of electrons because we didn't have an idea in slightest of our dreams. Let me rephrase it. We didn't have a slightest idea even in our dreams that electron will behave as a wave. But it accidentally proved the de Broglie hypothesis, wave nature of scattered electron. So somehow there was a leakage in the chamber and air oxidized nickel, and then we heated it to deoxidize, but on heating nickel resulted in crystallization and it formed well-defined structure, and hence you get the diffraction grating like structure, and hence diffraction happened. My god, nature works in weird ways. Electron bombarded, shown diffraction instead of mere scattering. Electron has wave nature similar to X-ray diffraction. Blah blah. What are the observations? For a particular kinetic energy of electron, we have a peak at a particular angle, 55 degrees. Sorry, 50 degrees. 50 degrees the kinetic energy is 54 electron volt. Right. What is Bragg's law? Bragg's law is basically 2d sin theta is equal to n lambda, but ठीक है हो सकता. But what is theta there? Theta is glancing angle, the angle that it makes with the crystal surface. Phi is another angle that is called scattering angle. So we use glancing angle and we say, okay, what is d? D is the interplanar spacing between the crystal. So yeah, lambda practical is equal to 2d sin theta. Given d is 0.0909 nanometers, theta is 65 degrees, kinetic energy is 58 mega electron volt. Okay, makes sense. From de Broglie hypothesis, we find the wavelength by the formula h by root under 2me as 0.166 nanometer. The practical one, the one we got from experiment, was 0.165. So it was very insignificant. It was almost same. So we proved experimentally de Broglie hypothesis, and due to this hypothesis, we got the concept of matter waves, which will serve as the basis of developments in quantum mechanics. And this is a good conclusion, right? Now, so matter waves are waves associated with moving particles propagating in the form of wave packet with group velocity. How do you define a matter wave? Matter waves are waves associated with moving particles propagating in the form of a wave packet with group velocity, right? Denoted by a wave function, represents its state, right? So define matter waves. Matter waves are waves associated with moving particles traveling with group velocity uh, and traveling as a wave packet. Right. Probability density is the physical quantity that is oscillating. Right. Oscillating. Determination and prediction of matter wave, that is dynamics, is governed by Schrodinger equation. Uh, if we talk about determination in quantum mechanics, these are just expectation values. Psi is called the state of the system, denotes the state of the system. Psi is the wave function. State means it contains overall information of the system, every possible physical variable possessed by a system. For a quantum mechanical system, we can write psi as a function of position, time, and spin. All the past, present, future information prediction is contained in psi. So अभी तक हम लोग क्या क्या पढ़े? अभी तक हम लोग पढ़े वेव पार्टिकल डुअलिटी, उसके बाद हम लोग पढ़े डी ब्रॉय हाइपोथेसिस, उसका वेरियस फॉर्म्स, उसका वेरियस डेरिवेशन, फिर हम लोग आए एक्सपेरिमेंट्स ऑफ डी ब्रॉय हाइपोथेसिस अप्रूवल, तो जिससे कि हम लोग लेक्चर 2 में ही है ना अभी, शायद लेक्चर 2 में ही है। हाँ, तो डी ब्रॉय हाइपोथेसिस, उसके एक्सपेरिमेंट्स पढ़े, हम लोग डिवीजन जर्मर पढ़े, उसके बाद हम लोग आ गए मैटर वेव्स पे। मैटर वेव्स को हम लोग वेव फंक्शन से डिनोट किए, और अब हम लोग कैरेक्टरिस्टिक्स पढ़ेंगे वेव फंक्शन का। So it's a matter wave function, probability wave function. It's a complex number, represents the state. Psi square is called probability density. Complete function is a superposition of states. It is finite everywhere. It's square integrable, and the square integration should be finite also. That's what it means. हम कह रहे कि स्क्वायर इंटीग्रेबल है कोई फंक्शन, इसका मतलब है कि इसका स्क्वायर इंटीग्रेशन एग्जिस्ट करना चाहिए, मतलब फाइनाइट होना चाहिए. सो इट्स नॉट, मतलब रिडंडेंट है सब, कंटिन्यूअस एवरीवेयर, राइट. ठीक है. ऑर्थोगोनल एंड नॉर्मलाइज, इट मींस ket psi n is delta mn, which is 0. If n is not equal to m and if n is equal to m, it is 1. Also, for a normalized psi, you get psi square dx is equal to 1. And how it propagates, and is it monochromatic or polychromatic? It propagates as a group of waves, and it's polychromatic. It's a wave packet. So if we take non-relativistic case, in monochromatic, the phase velocity and group velocity are same. In polychromatic, they are different. And it is also necessary as well as sufficient condition for monochromaticity. आप just check कर लो कि VP और VG बराबर है कि नहीं. अगर बराबर है तो मोनोक्रोमैटिक है, अगर नहीं बराबर है तो पॉलीक्रोमैटिक है. VP का फॉर्मूला होता है ओमेगा बाई के, VG का होता है डी ओमेगा बाई डी के. If you calculate it for a non-relativistic case, you get Vp as V by 2 and you get Vg as V. So matter travels as wave packets or group of waves with group velocity equal to the velocity of the particle. ठीक है. In fact, आप characteristics of the wave function 9 characteristics है, अगर आप 9 बता दिए तो आप मान लेंगे. पहला, psi is a function of position, time and spin. It's known as matter wave function or probability wave function. Second, psi is a complex number. Psi square is probability density. Psi represents the state of the function. पांचवा, it's finite everywhere. छठा, it is continuous everywhere. सातवा, it's square integrable. आठवा, orthogonal and normalized. And एक छूट रहा है. हाँ, that is the complete wave function is a superposition of base states. Right. So superposition theorem ही छोड़ दिए थे नहीं. So case 2 is the relativistic case, and you get Vp is equal to C square by V. So C square by V is equal to C, which is not is greater than C, which is not possible. So, and also if you calculate using E square is equal to P square C square plus m naught square C to the power 4, you differentiate it, you calculate dE by dP, which is the wave velocity, you get V. Right, that's no problem in wave velocity, but there is a problem in phase velocity. It comes greater than V. So it's a hypothetical concept. You cannot interpret it as velocity of some particle. 2 लेक्चर खत्म हो गए, अब हम लेक्चर 3 में जा रहे हैं. Lecture 3 starts with the second topic that is mentioned in the syllabus, is Heisenberg's uncertainty principle. It states that it is impossible to devise an experiment that can measure two complementary variables to arbitrary accuracy simultaneously. और अच्छा statement फिर से बोलेंगे हम लोग. Heisenberg's uncertainty principle states that it is impossible to devise an experiment that measures two complementary variables to arbitrary accuracy and simultaneously, right? So complementary variables are conjugate, canonical conjugates, and Fourier transform duals like position and momentum. Delta is called the uncertainty or the error or the spread. More precisely, we know the position. More precisely, we know the position. Less precisely, we know the momentum and vice versa. ठीक है. अगर आप देखें कि 2 ± 1 लिखा हुआ है, फिर 2 ± 0.1 लिखा हुआ है, फिर 2 ± 0.02 लिखा हुआ है, यहाँ प्रिसीजन बढ़ता जा रहा है because the spread gets smaller and smaller. It is not associated with the I feel tired. It is not associated with the issues or flaws with the observer, right? Issues or flaws with the observer. ठीक है. Intrinsic property of quantum mechanical system which cannot be seen on the microscopic level and which is fundamental to the system. It helps us to predict the probabilistic behavior. ये सब characteristics हैं. Arrange what? Okay. ऐसे लिखा हुआ है ना. A range, not arrange. A range. A range can be given not the exact value of two canonical conjugates. हाँ ठीक है, generic बात. Three forms of Heisenberg's uncertainty principle: delta x into delta px greater than or equal to h cross by 2. It is used in electron microscopy, quantum cryptography, and Q dot technology, quantum dot technology. Delta E into delta T greater than or equal to h cross by 2. It is used in quantum optical communication, particle collider experiment, ultra fast laser spectroscopy. Delta theta into delta L, where L is the angular momentum, greater than or equal to h cross by 2. It is used in MRI, NMR, ESR, and atomic clocks. Right. ये आपको बार बार रटना पड़ेगा एक्चुअली. सो ठीक है, और तो कुछ नहीं है. यहाँ तो सब ठीक है. Position, okay, this is generic, nothing to worry about. राइट, यहाँ भी कुछ नहीं लिखा हुआ है, इसका कोई मतलब नहीं है. डेल्टा ई इंटू डेल्टा टी, ओके, you multiply it by that and you get something. Okay, makes sense. These are manipulations, you cannot write these in exams. Experimental verification of Heisenberg's uncertainty: gamma ray microscope, double slit interference, single slit diffraction. ठीक है भाई. Some issue here. Oh my god. Damn, dude. Gamma ray microscope, double slit interference, single slit diffraction. Let's see single slit diffraction of electron. So delta py is equal to 2p sin theta, delta y sin theta is equal to lambda first order diffraction one slit slide. So when you multiply the both, you get 2p sin theta into lambda y sin theta, and you get 2p lambda, and you get 2h, which is greater than h cross by 2. So okay. So for a single slit diffraction, basically आप एक तरीके से प्रूव कर दिए sort of कि Heisenberg's uncertainty principle holds true. It means nothing. It's just focus on order rather than exact values in derivation, but be cautious in numericals. Okay. Gamma ray microscope experiment is a thought experiment based on photon colliding with electron. So if it happens, you can write delta x is the limit of resolution lambda by 2 sin theta, delta px to h by lambda sine theta. If you multiply both, you get h cross, okay, which is greater than equal to h cross by 2. Okay, ठीक है, मतलब nothing big. एप्लीकेशंस ऑफ हाइजेनबर्ग्स अनसर्टेनिटी प्रिंसिपल, आपको बस इतना याद रखना है कि आप एक्सपेरिमेंटल वेरिफिकेशन 3 तरीके से कर सकते हैं. गामा रे माइक्रोस्कोप, वाओ, गामा रे माइक्रोस्कोप, डैम पीपल, गामा रे माइक्रोस्कोप, फिर से experimental verification of HUP. How can you do that? Gamma ray microscope, single slit diffraction and double slit interference, right? ठीक है. Applications of HUP, Heisenberg's uncertainty principle. First is natural width of spectral lines. ठीक है, natural width of spectral lines, I get it. वहां पे आप डेल्टा E इंटू डेल्टा टी ग्रेटर देन इक्वल टू h क्रॉस बाई 2 कर लेते हो. सो वहां से आपको एक रिलेशन मिल जाता है, द मिनिमम सेपरेशन बिटवीन frequencies delta nu minimum is 1 by 4 pi delta t. How do you arrive at it? How do you arrive at it? You arrive by manipulation. ठीक है. So for ground state you have is there a problem here? Okay, excited state, okay, makes sense. Energy will be in discrete energy levels, that is finite in small widths between levels, giving rise to energy bands. Here when we go from lower to higher state, we can say that delta t, the transition time, is decreasing, so delta nu will be increasing. So change in frequency. So broadening of spectral width happens, which has applications in atomic and molecular physics, because delta t is decreasing, the transition time is decreasing. Non-existence of, पहला क्या था, broadening of spectral lines, natural width of spectral lines. दूसरा है नॉन एग्जिस्टेंस ऑफ इलेक्ट्रॉन एंड एग्जिस्टेंस ऑफ प्रोटॉन्स एंड न्यूट्रॉन्स इनसाइड न्यूक्लियस. So radius is of the order of 1 micro nano femtometer. So delta x will be an order of femtometer. So momentum should be of the order of minus 19. So energy required for that will become 100 mega electron volt, which is to reside inside the nucleus. A particle must have a minimum of radius of energy of 1000 mega 100 मेगा इलेक्ट्रॉन वोल्ट, बल्कि 1000, और उतना एनर्जी तो भाई इलेक्ट्रॉन का है नहीं, मास ही बहुत कम है, 1.6 into power minus 19 है, तो you cannot. Maximum energy an electron can have in the process of beta decay. In beta decay, an electron can have 2 to 6 mega electron volt based on different source, but not more than 10 mega electron volt. So maximum electron energy that electron can possess is less than minimum energy to reside inside nucleus. इसीलिए electron cannot reside in the nucleus. Whereas proton and neutron में rest mass energy ही 938 mega electron volt के around है, which is much greater than the required to stay inside the nucleus. Hence they are found in the nucleus. सो मिनिमम एनर्जी ऑफ अ हार्मोनिक ऑसिलेटर. दो चीज पढ़े हम लोग, ब्रॉडनिंग ऑफ स्पेक्ट्रल लाइंस पढ़े एप्लीकेशन में, दूसरा पढ़े कि व्हाई इलेक्ट्रॉन्स कैन नॉट रिसाइड इन द न्यूक्लियस, तीसरा पढ़ने आ रहे हैं मिनिमम एनर्जी ऑफ अ हार्मोनिक ऑसिलेटर. मिनिमम एनर्जी, 0 point energy, minimum energy that a quantum mechanical system can have, most stable state of quantum mechanical system, 1D oscillation. ओके, आप लिख सकते हैं डेल्टा एक्स इंटू डेल्टा पी एक्स ऑफ द ऑर्डर ऑफ एच क्रॉस. आप डेल्टा एक्स को लिख सकते हैं 2x मैक्सिमम, सो बिकॉज पोटेंशियल सेकेंड ऑर्डर का है, तो px आप निकालेंगे h क्रॉस बाई 2x, राइट. You put it in the energy expression, you get an expression h cross by h cross square होना चाहिए actually यहाँ पे. There's some problem here. H cross square by 8 mx square plus half mv square. M omega square x square. Shit. E is equal to h cross square by 8 mx square plus half m omega square x square. Now for minimum energy, you do energy analysis. Del E by del x is equal to 0 and del 2 E by del x2 is greater than 0 at x equal to x naught, and x naught is equal to, from there you get x naught is equal to root under h cross by 2 m omega, which is the displacement from mean position at which we have minimum energy. And if you put it, you get the minimum energy as h cross omega by 2, which is the 0 point energy. But in classical case, we have minimum energy 0. हमको कोई समस्या नहीं होता. यहाँ minimum energy 0 नहीं है. So the no oscillating system can have energy loss. Sorry, no oscillating system can have energy less than the 0 point energy. No system will be at rest even at 0 Kelvin. ये ज्यादा लिख दिए, ऐसे ऐसे नहीं लिखना चाहिए. 0 Kelvin पे what are we talking about? This seems stupid. ठीक है. तो helium does not solidify even at a very low temperature, right? Okay. तो ये क्वेश्चन पूछ सकता है बहुत छोटा सा 5 नंबर का कि why helium does not solidify at very low temperatures like 1 Kelvin. The answer is it's very light, so it has very low angular frequency. I don't know the correlation, but याद कर लेते हैं. So it has a very high minimum point energy, 0 point energy. So that's why. चौथा एप्लीकेशन है Yukawa meson theory, which was used for the prediction of mass of pi mesons. So exchange of pi mesons in nuclear interactions. We consider R of the order of 10 to the power minus 15. Okay, makes sense. So again, we are using energy time uncertainty principle, and you get m pi greater than equal to h cross by 2 rc. Okay, m कहाँ, अच्छा m तो निकाले. It comes to the order of 10 to the power minus 28 kg. So we cannot find any pi mesons which will have the mass less than h cross by 2 rc, which is of the order of 10 to the power minus 28 kg. ठीक है. So in 1947, people discovered pi meson, and it came to be 130 mega electron volt. Theory predicted 130 mega electron volt. Right, 140 and 130. Now, ground state energy of hydrogen atom, you can do the same analysis and find that the expression for energy can be written as h cross square by 2m r square minus e square by 4 pi epsilon naught r. And if you, for minimum energy, you differentiate, you do energy analysis, and you find that R naught का value आता है 0.529 angstrom, and energy comes out to be minus 13.6 electron volt. These are standard values. Third lecture is finished. Last lecture for today that we will revise is postulates of quantum mechanics. I'm already tired because I have to continuously speak, but we'll still do it. It's some 10 pages, 11 pages. Postulates of quantum mechanics, some underlying assumptions that are considered always true and based on which we formulate the complete theory. Postulates helps in describing and predicting the system. तो पहला postulate है the state of the system. The state of any physical quantity is specified at each time by a wave function, a state vector in a Hilbert space. ठीक है, makes sense. Psi को कहते हैं state of the system in Hilbert space. ठीक है. अब psi अगर r और t का फंक्शन हम कहेंगे इट्स अ पोजीशन वेव फंक्शन. अब p और t का फंक्शन है मोमेंटम वेव फंक्शन. एक कंडीशन है कि इसका डेरिवेटिव भी फाइनाइट कंटिन्यूअस और स्क्वायर एंड सिंगल वैल्यूड होना चाहिए. और प्रोबेबिलिटी डेंसिटी क्या होता है? using the Bond's probabilistic interpretation, mod psi square को हम लोग interpret करते हैं as probability density, probability of finding the particle's position as p. यहाँ पे dx भी लिखा होना चाहिए actually. You know, this is a blunder. Wave function should always be normalized. ठीक है, इतना तो जानते हैं. ठीक है. Not normalized. So normalizing factor is a constant that should be multiplied with the wave function to make it normalized. What do you mean by normalized? The wave function is said to be normalized if mod psi square dx integral infinity to infinity is equal to 1. ऐसे define कर देंगे. It follows superposition principle. Any superposition of state vectors is also a state vector. ठीक है, makes sense. ये सब कुछ पहले ही हो रहा है, मतलब लाइक फर्स्ट पॉस्टुलेट में ही ये सब डिफाइन कर रहे हैं. क्वालिटी डेंसिटी हम डिफाइन किए, नॉर्मलाइजेशन हम डिफाइन किए, सुपरपोजिशन हम डिफाइन किए. ये सब सिर्फ स्टेट वेक्टर के डिफाइन करने से ही निकल जाता है. ये सब भी होता है भाई. ठीक है, कुछ क्वेश्चंस हैं, इसको तो प्रैक्टिस करना होगा. ऑब्जर्वेबल्स एंड ऑपरेटर्स. सेकंड पॉस्टुलेट. टू एवरी मेजरेबल क्वांटिटी ए physical observable, there corresponds a linear Hermitian operator A cap, eigenvectors of which forms a complete basis. अच्छा, तो फर्स्ट था कि every physical system can be represented by a state vector in Hilbert space. ये था ना. अरे हम इसको याद नहीं किए, ये रह गया. देखो ये फॉर्मूला यहाँ पे था. The state of any physical quantity, this state of any physical system होना चाहिए. physical quantity क्या होता है? physical system होना चाहिए. मतलब स्टेट तो किसी फिजिकल क्वांटिटी का थोड़ी होगा जी, सिस्टम का ना होगा. चलो हम लोग 5 फार्मूला रटते हैं. फॉर ए ग्रेटर देन 0, इंटीग्रल माइनस इन्फिनिटी इंटीग्रल e to the power minus ax square dx is root pi by a. Integral minus infinity minus e to the power minus ax e to the power 2bx dx is root pi by a. It is e to the power b square by a. Integral minus infinity x into e to the power minus a x minus b square is b root pi by a. Integral infinity minus infinity x e to the power minus ax square is 0, and then x square e to the power minus ax square is 1 by 2 root under pi by a cube. ठीक है. Second postulate बोलो, to every measurable physical variable, physical observable, there corresponds a linear Hermitian operator A cap, eigenvectors of which, I said which, shit man. To every physical observable, there corresponds a linear Hermitian operator A cap, eigenvectors of which forms a complete basis. So position operator, momentum operator, blah blah. You do some manipulation, you pretend that you have derived it, but you don't really derive it. Px cap is equal to h cross by I del by del x, right? Yes. So kinetic energy operator is minus h cross square del square by 2m. You pretend that you derive it, but you really don't. Yeah. Again, you do this energy nonsense. Energy is I h cross del by del t. You pretend you derive it, but you don't. Third postulate. Measurement and eigenvalues. Every measurement of a dynamic variable can be represented by the action of the corresponding operator on the state function. So every measurement of a dynamic variable corresponds to the action of the corresponding operator on the wave function, on the state vector. So if the result of measurement of A on state this is an, the state of the system immediately after the measurement changes to psi n. So every measurement will perturb the system, right? Right. Okay. Right. Makes sense. Probabilistic outcomes of measurement. The act of, why do I do this? Yes. Probabilistic outcomes of measurement. The act of measurement changes the state from psi to psi n if the system is directly in eigenstate psi n of a cap. A measurement of a cap will give certainly probability as 1 to corresponding eigenvalue. अच्छा ठीक है. Probabilistic outcome of measurement. The act of measurement changes the state from psi to one of its state vector psi n. If it is already in psi n, the probability will be 1 and so on. And fifth, time evolution of a system. तो आप पांचों ना लाइन से बता दो. State of a system, observable and operators, measurement and eigenvalues. Uh, you have this. Mm, what do you have? Acha, probabilistic outcomes of measurement, and you have time evolution. Yeah, time evolution is just, the time evolution of the system is given by the time dependent Schrodinger equation, and Schrodinger equation is h cap psi is equal to e psi, and you have this. Yeah, this is simple enough. Also, one very crucial thing: if you use time dependent Schrodinger equation, you derive and you find the time dependent part using separation of variables comes out to be an a sinusoidal function a e to the power minus e to the power minus I e by h cross into t. So every quantum mechanical system will evolve with this temporal component. Yes. तो आपको कभी भी टाइम एवोल्यूशन की चिंता नहीं करनी है कि वो कैसे इवॉल्व करेगा, उसका फिक्स है. Oh, we did it. There you go. There. Oh shit. There you go, guys. We did 4 lectures revised, and now I'll end this. Next video will revise from 5 to 8. Thank you so much. How do you end this?